Hi, everyone. We're just going to give it another minute. Thank you for joining us, and then we will get started with our Hudson River Field Station session very shortly. Thank you. Okay, great. So I think people are still coming in, but let's get started on time. Thank you to those of us who've joined us and have logged on. So welcome everybody to another session in Lamont's virtual open house. And welcome to our session today, our home on the Hudson, the LDEO field station. So for those of you who are just joining us for the first time, I just wanted to talk to you a little bit about, let you know about Lamont, and for those of you who might not be familiar with us, we are an earth science research organization located in Palisades, New York, and we are part of the Earth Institute at Columbia University. And the Earth Institute is made up of many different scientific researchers and faculty members and staff members who all work on addressing issues of climate change and the climate crisis and sustainability challenges and what we as global citizens can do. So we are, and Lamont is the biggest part of the Earth Institute, and Lamont was established in 1949. Since then, it was in the tradition of the first director of Lamont, Maurice Doc Ewing. He wanted to open up the Lamont campus and our facilities to the community, our neighbors and students and the Columbia community for one day a year. And that is how Open House started. And we have proudly continued that tradition. And this is our first ever virtual open house. And we're so glad that you are all here to join us for our sessions. Everything is being recorded, so if you do end up missing a part or if you want to go back and rewatch some of our great talks, you definitely can. Everything is going to be on the Open House website. So today we are, our theme for the day is the Hudson River, and it's a wonderful place and lots to learn about the Hudson. And we're very lucky to have Margie Turin and Laurel Zyma joining us for this session. And I'll let them introduce themselves, and just to let you know that we're going to be using the Q&A box throughout the session. Margie and Laurel are going to take turns talking, and then while one is talking and the other is kind of hanging out, we'll definitely keep an eye on the Q&A box. So feel free to type in any question you have in there, and they're going to take you kind of on a virtual tour and field trip of this wonderful space. So ladies, take it away.
All right, great. Well, my name's Margie Turin, and I have been a part of Lamont for over 20 years and have spent a lot of time working on the Hudson and in a variety of different projects, and really love that location, love the space, and love all of the partners that we work with on the Hudson River. And I'll turn it over to Laurel and she can introduce herself.
Hi, everybody. My name is Laurel Zyma. I'm the Education and Outreach Coordinator at Lamont. I've been here for about 2 years now, and one of my favorite parts of the job is working around the Hudson River. I have a background in marine biology, so I'm really excited to share with you guys what we've created for today. We have a field station at the end of Piermont Pier, which is just about 5 miles up the road from Lamont's main campus. And that's where Margie and I spend the bulk of our time, especially in the spring, summer, and fall months. So while we can't unfortunately bring you all to the field station today. We're going to try and bring the field station to you guys through a couple videos. So I'll just launch right in and play the first video. If you have any questions, feel free to use the chat box and we're going to discuss after each one. So the first video, we are going to be looking at our location on the Hudson, which is considered this wide bays region.
We wanted to take a minute to introduce to you our space in the river. So we're in Rockland County, and this is looking at the land area around the Hudson. We have the Hudson kind of cutting up through the middle of this. And you'll see that the Hudson Highlands, which is this incredible stretch of mountains, is kind of framing the top of our section of the Hudson River. And we're gonna zoom in a little bit more and kind of really get up close and personal with some of the wonderful rock formations that form our area. All right, so we're gonna take a little bit of a deeper dive into our part of the Hudson River. So if you were to start down here, you would have the George Washington Bridge, and this is where Lamont is located. Our field station, which is where we are right now, is right down here at the end of Piermont Pier. And this is a mile-long pier that extends well out into the Hudson River in this really wide section. So this is the widest part of our river, Haverstraw Bay and Tappan Zee, this big kind of bays area. This is the Palisade Sill, which is a 200 million plus extent of rock that actually formed. It was an intrusion that pushed up through the land at that point and is so hard and rigid that it's remained. And the Piermont Pier was actually built with quarried rock that came from that Palisade Sill. The quarries in this area no longer are active, but we do still have an active quarry in Rockland County. This is up here by Haverstraw, and you can see this kind of deep bowl that's been formed by just pulling that rock material out. So this 200 million year old, very resistant diabase or basalt that exists is really framing our part of the Hudson River, providing this wonderful backstop. You can see that down by Piermont Pier, there's the marsh. This is our Piermont Marsh. It's the largest brackish marsh in the Hudson River and provides us kind of an interesting environment or ecosystem in which we are influenced, even out here in the middle of Piermont Pier. And one other thing I want to mention is the colors on this map. So this very, very deep dark blue that's up here towards the north of Rockland County is actually a deepening that goes in along in the river. So as we move into the Hudson Highlands, the rocks are very resistant and it forces the water to really carve down more deeply. Whereas this part of the river is really very, very shallow and very productive. Okay, great. So that's a wonderful introduction to our location in the Hudson River. We are as kind of mid-center in the Hudson, if you want to think about it that way. This bays, we're really at River Mile 25. So we're not, I guess mid-center would be an inappropriate term. We're still fairly far down in the Hudson. The Hudson estuary is 153 miles. So the estuary section is about half of the entire Hudson. So as you can see, we tip way down towards the bottom. I think about us as being in the middle just because we have this wonderful wide reach in the estuary, and we're in what we would call the brackish section. So an area where we have the influence of the Atlantic Ocean and also have a strong freshwater influence as well. I see some questions coming in. We have Ian has been asking a range of different questions. And so we're absolutely happy to answer some of those. You've gotten into a lot of fish right off the bat, and we are going to have a chance to look at a fish video and talk about it. But I think just you were talking about top predators in the Hudson, and I think we would be remiss if we didn't mention that really striped bass is considered one of our top predators in the Hudson River. It's a voracious eater. It's a very persistent presence, although our numbers have declined a little bit, not just in the Hudson, but along the whole entire Atlantic seaboard recently. We're still seeing striped bass in good numbers and certainly would consider them a pretty strong predator. Laurel, do you want to answer any or address that in any way beyond?
No, I think you covered striped bass. We're actually going to talk, if we have time, we have a fun little video because we actually have a taxidermy striped bass in our field station. It's this amazing pregnant female that was caught many, many years ago. Wouldn't be allowed to catch such a fish today, but it was a local fisherman near Cornwall, New York, who then donated this fish to us to be used for educational purposes. So it's a wonderful opportunity to talk about the striped bass as a predator and also just look at some of its features. And Ian, you also said that there are no sturgeon or any of that. And I just did want to address that because we actually do have sturgeon in the Hudson, and we have the short-nosed sturgeon that live most of their entire lives in the Hudson River estuary, and then the Atlantic sturgeon that are a migratory species that really use the Hudson as a spawning ground. And the area that we have our field station, this wide bays, Haverstraw Bay section, is a critical area for juveniles and an overwintering area for sturgeon. So it is a really key habitat for them to thrive.
And just one other thing about sturgeon. So they are actually bottom feeders. They have barbels, they eat very small things. So I wouldn't consider them to be a top predator. That's really not their situation.
Right. Such a good point. They're big, but they're not a top predator. I also the tool that Margie was using in the last video is this amazing topographic map that we developed in the past year that we use with students to really allow them to dive into the spatial geography of our area and talk about some of the geology of our area as well. It's this tactile map, so students can actually touch and feel how the elevation is changing in different areas. So we love to use it. It's just such an amazing tool for any teachers who are thinking about coming for a field investigation one day. And we do not do any scuba diving in our studies, but we do have scientists at Lamont that do a lot of diving all around the world. Okay, so since we were talking so much about fish, let's jump into our next video. It is actually looking at some of the fish that we catch in the Hudson and the fishing method that we primarily use. Hi everyone, we're out here at Piermont Pier with the Lamont Doherty field station crew. Madeline over here and Maura that are gonna lead us in our first seine. We are using a seine net technique. So a seine net is this giant wall of net that is walked through the water by two people holding the dowels on either side. You can see the seine net has floats on the top to make the net nice and stretched out to the top of the water. And on the bottom, there are actually weights to drag along the bottom of the river. So anything in the path of the seine net, from the very surface to the bottom of the riverbed, we are going to catch up in this seine net.
Temperature of the Hudson River. I'm going to be going out about waist feet deep. I'm going to put this thermometer in there for about 5 minutes and then I'll come back with you with the temperature.
In order to understand what fish live in our section of the Hudson, it's important to take data about what the water quality is like. So one thing we are going to do is test the salinity of the river right off of Piermont Pier here. So what I'm going to be using today is a refractometer. The way that we're using this is you just take a sample of water here. We're going to put it in the refractometer slide. Just a couple drops to fill it up. Shoot that away. You put the slide cover on top, and the way that a refractometer works is that you have to little male.
How do you know it's a male?
Oh, great question, Maura. So, if you look at the belly of these blue crabs, first you can tell it's a blue crab because they have these swimmerets that help them to move very quickly throughout the water and very gracefully. In Latin, their name actually translates to beautiful swimmer. Anyway, this blue crab is a male because we can see on his belly he has this point right there. Kind of looks like the Washington Monument. That's how you know it's a male. If it was a female, it would have this apron going across its belly on like pretty wide, and it kind of looks like the Capitol building. So if it's a Washington Monument, it's a male. If it's the Capitol building, it's a female. The other species that we caught today is called an Atlantic silverside. This type of fish loves salt, given the Atlantic in its name. It loves the salt of the water. They're called silverside because if you look closely, you can see there's this bright silver strip going horizontal across its body. These guys have a pretty flat face with an upward facing mouth, which means they eat from the surface. Their pectoral fins are also set pretty high on their body as well, which is an indicator that they live at the surface. These guys are actually cousins to the flying fish. So if you ever look at a flying fish and you look at an Atlantic silverside, they have a lot of similar features. All right. So we just kind of took you through what a day would be like if you were to join us for a Science Saturday event. So down at the field station, we have public events on Saturdays during, especially the summer months and the spring and the fall, where we engage the public with real field collection, and then they help us collect this data and they have this amazing field experience. So we'll do some water quality tests or water chemistry tests, and we'll take everyone seining and talk about the different species that we find. So that was a pretty, as you could tell by the water temperature, it was pretty warm that day. That was a day in August. So we got to go out and film, which was nice.
So one of the things that Laurel did mention while she was there, she was measuring the salinity, and you'll notice that her salinity was 5 parts per thousand. I was down in the water today a little bit ago, and it was 13 parts per thousand. So quite a bit higher in terms of salinity. And again, we're situated fairly close to the Atlantic, about 25 miles straight up from the Atlantic Ocean. The Atlantic itself is 35 parts per thousand. So we are definitely in a section that gets the salt. And this time of the year, we would have a little bit more salt on normal situations. Sometimes there's a big rain event and we would see that salt pushed a little bit further down the river. But this is a time where we would expect to see a little bit higher levels. But it's always fun to test the salinity because you don't know what you're going to get. It varies. It's very dynamic. And of course, the fish that live in our part of the river, which is what we're talking about now, are able to adapt to a little bit of that variance of being a little bit salty or a little bit fresh. And I see we have a variety of questions about fish. So one of them, maybe I'll take one and I'll pass one off to you, Laurel. So how many species live in the Hudson? So we have somebody that actually tracks that. A colleague of ours, Tom Lake, who works for the DEC, has a running list of fish. And Ian has asked a lot of questions about fish. You might be interested in tagging on with Tom Lake and figuring out a little bit more about the history of the fish that have been in the Hudson River. So there are a variety that are native, but there are also new species that are moving into this area now that the water is warming. We're seeing new fish coming in on the warmer currents. So we have fish that come in to migrate. We have those that spend their entire lives here. And then we have some that just kind of catch a current and end up here. And at this point, they've identified over 230. So quite a nice number.
Yeah, we actually have an event happening tomorrow where we have 50 plus partners of ours that are going to go out and sample on the exact same day in different locations of the Hudson, and just to have collect data continuously, have this long-term data set to better understand what lives in the Hudson and how the Hudson is changing. And so we're, fingers crossed, we're finding our new Hudson River fish tomorrow.
And somebody asked, Allison asked how deep the Hudson River is. It's certainly variable. At its deepest point, which is up by West Point, at what we call World's End, it's over 200 feet deep. Down at the end of Piermont Pier, there's a deepened channel because you'll see in one of our videos, perhaps today, that we had a ship that came in and docked there in the 50s and in through the 60s, et cetera. And so it was deepened to about 18 feet, so the ship could come in. But for this part of the river, it's actually fairly shallow on the edges. The center has been dredged, so most of the Hudson River you will find is at least 30 feet deep, in many areas much deeper than that, and that's for the boat traffic that moves all the way up to Albany and back, bringing everything from fuel to the windmills, et cetera. There's a lot of material that's actually moved up and down the river.
And Lamont was also a part of the benthic mapping project, which looked to map the bottom of the Hudson River all up and down. And so you can actually look at some of these maps online. We can also share that link at the end if you want to take a deeper dive into that project.
And just to tip on that for a second, that really cool tool that I was using in the first video, the data in there is actually from that benthic mapping program. So the depths are actually depths that we measured as we completed that program. And so there was one other question about fish and how many fish we catch. And I think for the most part, we have a steady range of about 40 different types of fish that we have actually identified and find what we would call regularly down at Piermont Pier through the spring, summer, and autumn. But we're always finding new things, and we have not been able to really do a comprehensive study of this area. Even though we've used that location and we've been sampling for many years down there, we haven't had the field station until the last year or so. And so that gives us an opportunity to really do a much more complete study, which is going to be really fun.
That's great. Okay, I don't think there's any more questions for now, so we can pop into our next video. We just saw snippets of the water chemistry that we do with some of our kits, but now we're going to take a deeper dive into water chemistry and look at another tool that we have at the field station.
One of the really fun things that we have here at the field station is we are linked to a real-time monitoring system. We have our own sound right off the end of the pier that's measuring both water quality, and then up on the roof we have a weather station, so we get both of those pieces of information. This is Lamont Station here at Piermont, but we're part of a larger network that includes other partners and is really organized by the DEC, the New York State DEC. So we're going to dig into each of these variables and just spend a minute talking about what the data is that we're seeing. So dissolved oxygen is referencing the amount of oxygen that's available for the biology in the river, and you can see that it kind of rises and dips in a regular cycle, and that would be related to our tides. So you can see that an incoming tide will bring us a little bit more oxygen than an outgoing tide. And part of this is because of our relationship with Piermont Marsh, which is just to the south of us. A lot of that oxygen is absorbed and breaking down the biology in the marsh. So you can see that the oxygen levels dip fairly low to a little bit below 2.5 parts per million or milligrams per liter. And yet we see them rise up to about 8 parts per million or milligrams per liter. And we would consider a really happy, healthy system to be between 5 and 11 milligrams per liter or parts per million. So this doesn't mean our system's not healthy. It just means that we are seeing the effect of the marsh next to us. Okay, and next we're going to move to water level, and you'll see this wonderful rise of high tide, low tide, high tide, low tide. Over this 3-day period, we would have 2 highs and 2 lows each day. And that high tide is bringing water from the Atlantic Ocean as it moves into the estuary. And then our low tides are taking that water back out, so we bring the fresh water down with us. And we're going to move on to talk about salinity next. And we'll see that there's a little bit of a relationship between those tides and the amount of salt that's in our part of the estuary. So you can see this would be a high tide. It's bringing a nice salty mix with it. And then as the low tide moves out, you'll see that the salinity levels drop. This is a saltier time of year for us in Piermont. We're looking at ranges around 10 parts per thousand all the way up to almost 14 parts per thousand. Our salt water in the Atlantic Ocean is about 35 parts per thousand, so we're about a third the strength of a true ocean water at this point. And in the estuary, we range all the way from where we have the salt in the Atlantic Ocean up to Albany, where we have really just very, very slight amounts of salinity, where they're measured in the parts per million, less than 100 parts per million. And that part of our river we would consider fresh. And then lastly, we're going to look at water temperature. So water temperature also is related to our tidal system, but more than that, our water temperature tends to be related to time of day and seasonality. So we would expect to see warmer water when we have a nice sunny day. Right now it's overcast outside, so you'll see that even though we're in the middle of the day, we're really not seeing any effect from the sun because it is hidden behind the clouds and the rain. Whereas yesterday we would have seen those sunny peaks. And so our temperature is very much related to the seasons. So you'll see that in the summer months we have a very high temperature. In the winter months we have very low temperature. And then look at that wonderful relationship with dissolved oxygen. So as we have very high temperatures in our water, our oxygen levels will drop. They'll take a big dip down. Whereas in the winter, we'll see the opposite. We get much higher levels of oxygen as our temperatures cool. And it's really evidenced in this very cool set of data.
We also use a variety of tools to measure the water conditions off of Piermont Pier, including a refractometer and a hydrometer to measure salinity, an anemometer to measure wind speed. We have a kit to measure pH, a thermometer to measure water temperature, and a kit to also measure dissolved oxygen. Okay, so
while we don't have any questions open that I can see, I think it is important to just think about why we actually collect these measurements. So the fish are super engaging and we love pulling a seine net and pulling in the different fish, but without any context around them in terms of what are the oxygen levels and how much salt is in the water, what's the temperature like, we really can't understand why we're pulling in what we're pulling in. So we really need to look at the whole thing as a system. And so every investigation that we do really combines multiple parts. We would never just go out and pull a net through the water and grab some fish without really trying to understand what is their setting like? What's the salt like? How much oxygen is there? What is the water temperature? All of that is like putting the number on a street address so that we can actually make sense out of it.
That's so true. I mean, we last summer had a great opportunity to go seining almost every weekend, and we started to catch species that we had not seen before. And so it's so important to take this extra data so then you can kind of understand why you might be seeing this species, what changes are happening in the water that could drive this species into our area that might not have been there before. But this is to be found out because we have only had a couple years of data. We'd want to look over a longer term of data to see how things have changed. All right, no questions. We also at the field station focus on the invisible components of the river. So when we talk about the invisible world, we're talking about things that you can't see with the naked eye. We have some pretty cool tools and equipment that allow us to uncover some of these things. And so we're just going to share that with you now. Here at the Hudson River Field Station, we like to investigate and explore all parts of the Hudson River system, and that includes the invisible components. So there are things that are existing and living in the Hudson River that we cannot see with the naked eye. So instead, we have to use some microscopes and tools to be able to uncover these things. Looking at the field station are microplastics. Microplastics are a common form of plastic pollution ranging from 5 millimeters to 1 nanometer. So for reference, an ant is around 5 millimeters, so that would be on the larger end of a microplastic piece, and a DNA strand is 2.5 nanometers. So a microplastic could even be smaller than that. So we definitely need these microscopes to be able to see these different sizes of plastic pollution. Now, plastic can be subcategorized into two groups. There are primary microplastics, which are microplastics created and manufactured to be small. Some examples of these are microbeads, which are commonly found as an exfoliant in toothpaste or face wash. There are microfibers, which are synthetic fibers used to create garments and clothing. And then we have nurdles and pellets. So nurdle is a virgin form of plastic that is shipped all over the world to be sent to manufacturing companies to use this plastic in creation of other plastic products. Now the other group are secondary microplastics. These microplastics are formed from the degradation of macro or larger pieces of plastic. And this can happen from wind, physical force and fragmenting of these larger pieces of plastic, and also photo degradation from UV rays, or even heat can break up plastic into smaller bits. A couple examples that you might see are fragments. So looks like a smaller piece of a bigger product with irregular sizes, shapes, and colors. We also have films, which are broken up pieces of, let's say, plastic bags or saran wrap. And then we have foam. So foam can be small little foam bits off of a styrofoam container. Unfortunately, we see all types of microplastics when we sample down here. We have the ability to take a water sample from the Hudson and observe whether or not microplastics are found in this area. This is something that we want to continue looking at down here. Another part of our invisible world are plankton. So while the Hudson isn't known as being a plankton-rich body of water, we do have plankton here. And plankton are these microscopic organisms that are really critical as the base of the food web. Now, we have both types of plankton, both zooplankton, which are animal plankton, and phytoplankton, which are a plant form of plankton or a microscopic algae.
Cocopods are the primary zooplankton in the Hudson River estuary. They are a group of small crustaceans, and they really dominate in the assemblages of coastal environments. We have three main players of cocopods in our section.
Our first cocopod is Amora affinis. This species thrives in the estuary during the spring and fall seasons when it's a little bit cooler. So in the springtime, we have lots of Amora affinis. But as the water temperature increases into the summer, it's then replaced by a different cocopod called Acartia tanza. But then, as we move into the fall, temperatures cool off, Amora affinis comes back into the Hudson River estuary system. The other species, Acartia tanza, that we just mentioned, favors these warm water temperatures. So they are moving into the Hudson estuary during the summer months, anywhere between July to September. And our last species of cocopod, Acartia hudsonica. This species is found in the temperate boreal region, and they are known to be found in estuaries specifically. Now in the Hudson, they typically peak around May when temperatures are just starting to warm. However, in response to global warming, we can see that the species' peak is moving even earlier in the season toward March. So it just goes to show that global warming and climate change has an impact on all parts of the ecosystem, including this invisible world. And we have two major types of phytoplankton in the Hudson River estuary. We have diatoms and dinoflagellates.
Diatoms have a cell wall that's made out of silica, and they are beautiful. They are in different shapes of zigzags and ribbons and fans. So they're really fun to look at under a microscope. And then we also have dinoflagellates that are characterized by having this whip-like flagellum. We also observe the river bottom sediments here at the field station. So because we are a part of this wide section of the Hudson, the water is moving a little bit slower in this area, which means that we have more sediment deposition in this area than others. And we can look and observe these sediments through sediment cores that we take right off of the pier here. Things that we might find in the sediment include pieces that tell us about the human history of this area. So we'll find pieces of brick, which is evidence of the brick making factory up in Haverstraw Bay. We can find pieces of coal that have fallen off of steamboats. We can find slag, which is from iron foundries, and concrete from construction. And we can even find diabase from the blasting that they did in the Palisades to collect that rock material. So here we actually have a sample from a sediment core taken just north of us by the Tappan Zee Bridge. You can see lots of these small sand grains, which is evidence of fast-moving water in this area.
Okay, so I see we do have some questions.
So the first one is, how did the Hudson River form? And so the Hudson is what we would call a drowned fjord. So it was carved out by ice, helped to do that original kind of carving. And then there were large glacial lakes that formed much further north. And as those kind of broke free of their stopping, it really filled in that fjord. So that's why we call it a drowned river valley. And so it was over a period of many years. So certainly nothing that happened in our recent history. But it's a really great question. And actually, if I don't know if you remember back to the very first section, and we were talking about the Hudson Highlands, that much more resistant section of mountains that exist, or range that exists at the top of our Rockland section. That very resistant area is where the river really had to work to carve through. And then in our area, the sediments were much softer. And so that's why we have such a nice wide section of the river. We had a lot of glacial clay in this area, and it's just allowed the river to widen and slow down a bit as it moves through this reach.
Great. And someone asked, how clean is the Hudson River? Do you have an estimate or answer to knowing how much plastic or waste is in the Hudson? Clean in terms of water quality, or clean in terms of, I guess, like plastic waste can kind of be categorized as two different things. So we can talk about the first one. Since the Clean Water Act, the Hudson has been cleaned up dramatically. It is so much better, and really an amazing body that people are recreating around. So we have people kayaking and canoeing and fishing and swimming. It's really amazing, and we want to continue to keep an eye on water quality and just continue to clean the Hudson. But it is much better. It's doing pretty well. And in terms of plastic waste, this is a tricky one. We and other colleagues are sampling plastic in the Hudson. It's hard to put a hard number on how much plastic, because these pieces are so small, and it's, once you pick it out of the Hudson, it seems like just in general, these pieces are hard to quantify. But one of the challenges is that we have, so in the city, so it's not near us in Rockland County, but in the city, we have combined sewage overflow. So, which means that all of our sewage water from our toilets and showers and all of our storm drain water are intended to go to the wastewater treatment plant to be cleaned, which in theory is a wonderful thing. But, New York City blew up with all these people, and it wasn't expected. And so now we have so many people flushing their toilets and taking showers that just a little bit of rain, 0.4 inches of rain in a day, can overwhelm this system where all that water can't make its way to the wastewater treatment plant, and instead it overflows out into the Hudson. So these combined sewage overflows, or CSO pipes, are allowing this raw sewage and storm drain water to flow into the Hudson. And if you think about any trash that's on the streets and that gets wrapped up into this storm drain water and flows right into the Hudson, you're adding more plastic pollution into this body. And because, as Margie already mentioned, we have this tidal system, we can see some of this waste making its way up the river system to us. You have to keep in mind, we're not that far from the city, so we can definitely see some of these challenges as well. So we do cleanups like locally on the pier, and we have an organization that we work with that also does a lot of cleanups in the Rockland community. It's really important, but I think you can clean up all the time, right? But it also starts from the consumer level. So we have to be more conscious in what we consume and how we use plastic, and we have to use it in a more responsible way. So that means avoiding using any single-use plastic, because you know you're going to use it for approximately 12 seconds and then throw it away when you're finished, which is so wasteful, and plastic never breaks down. So avoiding using single-use plastic, moving over to other forms of materials if you can, like metal or glass, would be a better option. So it just all comes down to making changes in our life. Okay, that was a long-winded answer, but I don't see any more questions. Maybe we can show the last video and just see if there's any more questions after that. So our last one, especially tying it all back to open house, we have had this long history. Lamont has had a long history with the pier. And so we just wanted to tell you a little bit about that.
So Lamont's history with Piermont Pier really started back in 1953 with the purchase of the Vima. So the Vima was our first marine-going vessel. It was actually an old sailing ship that was originally outfitted by E.F. Hutton in a very elaborate way, and then it was purchased several times since then, was part of World War II, and then ultimately in 1953, Lamont purchased that ship, and we needed a place to dock it. And so at that point, this particular pier was available, and we brought the ship in, and it became home port for us. You can see on this amazing map of all the different ship tracks that were collected by both the Vima and the USNS Conrad behind it, that we've had many, many years and many, many miles of data that's been collected around all of our oceans. So the Vima tracks are the blue ones, and the Conrad tracks are the red ones. Vima operated for many, many years, from 1953 to 1981, and actually was the first ship to log 1 million nautical miles collecting science data, which is an incredible landmark for us. So one of the fun legacy pieces that is really something we talk about a lot at Lamont is the fact that we have cores that have been collected all over the world, and that's really a piece that goes back to our founder, Doc Ewing. And Doc Ewing had a requirement that every day, minimum once a day, you would stop and you would collect a core, no matter where you were, whether you had a science question in mind or not. One never knows when that data will become useful or be the important piece in framing a theory or a hypothesis or a discovery. And so many, many, many cores were collected and are now part of our wonderful core repository. One of the pieces of science that we are most excited about at Lamont is the first world ocean floor map. And this was created in 1977. And it's really difficult to think about how this was actually put together. So collected on our ocean vessels were seismic lines, which are just black reflective lines that were spaced apart and really brought together just a series of data. which then had to be visualized, matched together, and put together to create this entire vision of what it was like underneath all the water in the ocean. Prior to that, there really was no understanding. It was just like a big bathtub. Now we had evidence of these incredible ridges that cut through different parts of the ocean floor. And it provided us with really the basic understanding of the shifting of our continents, so this plate tectonics and how seafloors spread. Marie Tharp was a really interesting person in that she thought beyond just putting together a black and white map, but she actually worked with an artist to develop this into a beautiful color display, which was launched through National Geographic. And now it's become really something that sat outside of a science laboratory and was in people's homes. It was something people could talk about. They could really get a better understanding and popularize this whole idea of the bottom of the ocean and what it must have looked like, and really got people thinking and questioning, which is what science is all about.
What a great way to end. Are there any last minute questions? All
Well,
right.
maybe we'll
You
just...
two,
Yeah.
I was just gonna say, maybe I'm trying to turn on my video here. There we go. I wanted to see if you could talk a little bit about day in the life as well. I know you might touch on that next session, but in case we have folks from this session who might not join us at the next one, if you could talk about day in the life and what that is.
Sure. So we've been partnering with the New York State for the last 18 years to run a program that samples throughout the entire estuary and even outside of that. So I know I said earlier, 153 miles is our estuary dimension. And we have thousands traditionally of students out sampling on the river on that day and then sharing their data. So collecting measurements. And again, we talked about the idea that these are systems. It's not just collecting one measurement. We need to understand the chemistry. We need to know what the tides are doing. We need to understand the weather. We need to really understand what lives in that part of the estuary. So we can put all this together to understand how dynamic the system is, how it changes, how it's the same in different places and yet different in others. So that's a program that has run, as I mentioned, for many years. This year, because of the differences in how our lives are with COVID, we're really unable to host students at the river, but we have a really strong group of partners who work with us annually to support our schools. And so they've agreed to go out and do some sampling for us tomorrow. And they'll be collecting videos and measurements, and then we'll be putting those together into 3 sections of the Hudson and sharing those back with students and schools so that they can actually understand not just one part of the estuary, but all 3 different sections and look at how they might be the same and how they might be different. And if you're interested in that at all, we would really love for you to reach out to us, and we can link you up with those videos and that data when it becomes available. I know that we're excited about it. We think it's going to be very different, but so much fun. And there are a lot of things it allows us to do that we haven't been able to do in the past, like showing different parts of the estuary and letting students do a much more direct comparison. I don't know if Cassie, we can put a contact information somewhere so that we can make this easy.
Sure. I can share it in the chat box with everybody. What would you like to share?
So why don't I just put, I'll put my email.
Sure.
And that way, I'm sorry, I forgot about that old chat box. I was looking at these questions.
Yeah, no worries.
And I just wanted to let you guys know, even if you're not a teacher, there is this amazing opportunity this year with Day in Life being virtual, in that we're going to be also doing a live Facebook event at each section of the Hudson. That's going to be on the DEC, the Department of Environmental Conservation's Facebook page. We are going to be sampling at Piermont at 11. A site in the city is going to be doing it at 10. And then I think upriver is going to be at noon. Is that correct, Margie?
Yes,
Okay,
that's
perfect.
right.
Got those right. So 10, 11, and 12.
Yeah, and I put the website for a day in the life as well as contact information if you need anything, but we'll be linking those videos there.
Okay, excellent. Well, I think that wraps up this session very nicely. Thank you, ladies, for sharing that with us and for taking us on a virtual trip to show us what the field station looks like and all the wonderful things that goes on at the field station. I am I'm answering this last question. It's about the packet, which I've just sent. And hopefully you are all able to join us for our next session as well, continuing the theme of the Hudson, but more specifically for educators or perhaps for parents who are helping out at home this year with schools and learning about how you can bring the Hudson either to your home or to school with you. So we'll wrap up here, and thank you very much for joining. Thank you, Margie and Laurel, and hopefully we'll see you at our next session.
Thanks,
Thank
everyone.
you so much. Bye.
Bye, everybody.